Moving on, now we'll start with your topic number 3, which is the waves and the particle nature of light. The behavior of waves. Okay, how do waves behave? Till now, we have talked about many properties, including the amplitude, wavelength, distance, displacement, time period, frequency of the wave speed as well. So now what is phase? All points in a wave will be at some position through their cycle of oscillations, and some of these positions in the cycles have their own names, such as peak, crest, trough, compression, rarefaction, and the remaining points through a cycle are also important. It's not just the highest or the lowest point that you talk in IGCSE, the crest, the trough. What about the other points? Aren't they important? Yes, they are important as well. And it's important to give them names as well. We describe any position through a cycle by a number referred to as the phase. अब वो नंबर in the form of radians भी हो सकता है, or that number can also be in the form of an angle in degrees. A complete cycle is considered to be equivalent to rotating through a complete circle. So the phase position will be an angle measurement where a complete cycle is equivalent to 360. Now one whole circle is what? 360. Then 360 थोड़ा सा पहले कौन सा पॉइंट होगा? It would be 310. Then उससे पहले 270 होगा. हाफ सर्कल पे अगर कोई पॉइंट है, लेट्स से वो 180 पे होगा. If I say there's a point at 190, so you'll go like this and then stop here, that this is the 190 point. 90 would mean what? This point right angle पे है. तो angles के through you have seen a protractor, right? There are all points, सारे angles के
Yeah.
through. That is how we are going to tell all the other points rather than the highest and the lowest one. क्योंकि अभी तक what have we been doing? We are talking about crest, we are talking about amplitude.
Yeah.
What about the other points? What about this point,
Mm-hmm.
this point, this point, this point? They all are going to have names now, and we are going to locate them either in the form of radians or in the form of angle. This point, ये आपका जैसे 90 डिग्री पे है.
This is
This is
90 degrees, right?
exactly 180 है, 270 है, 360 है. What about
But
a
would you use what was it called,
Mhm.
the retractor
No,
to
no, there's
find
nothing to do
the,
the protector. नहीं, protector कोई काम नहीं है. There's a formula and some conversions that is completely new in A levels that we'll do today.
okay, so I don't need to have I don't need to use it, I just
No, no.
calculate it.
Exactly, वो calculations है, ठीक है. अब एक point 270 280 पे वो यहाँ पे आएगा. This is the 280 point. This is the 300 point, 305 point, 310 point. It is quite common to measure phase in alternative angle units or radians, where one complete cycle is 2 pi radians, or in degrees we say it's 360 degrees. तो 360, आज conversions को देखो, 360 degree is equal to 2 pi radian, 180 degree is equal to pi radian, 90 degree is equal to pi by 2 radian, and 270 degree is 3 pi by 2 radian. These are some of the common ones. जैसे कि अगर आप देखो, 1/4
But
of a
what if I don't have the degree, but I need to find the degree? Would I use a protector then?
नहीं, you don't have to find. Why would you use a protector? We are talking about a wave. Wave के ऊपर आप कैसे protector
Okay.
रखोगे? हो ही नहीं सकता. How are you going to measure? कहाँ रखोगे? वो angles नहीं. It's just a term angles की. Angle doesn't mean you have to use a protector. It's a complete
Okay.
different thing. ठीक है. यहाँ पे you have to remember 90 degree means pi by 2 radian, और इसके अंदर आपको 4 वेवलेंथ आ सकती हैं. What does it mean? This is a whole wave. We divide this wave into 4 parts. One of the part is pi by 2. The other part is also pi by 2. Pi by 2, pi by 2. सारों pi by 2
Right.
को ऐड करोगे पूरा क्या बनेगा? 2 pi. Half of it would become pi. Even half of that as well would become pi by 2. So 90 degree का क्या मतलब है? It is pi by 2. And how many number of wavelengths? It's 1/4 of a wavelength. जहां ये वाला जो पॉइंट होगा, दैट इज हैविंग अ 90 डिग्री फेज. इन रेडियंट इट मींस पाई बाय 2, बट इट्स 1/4 ऑफ अ वेव. पूरी वेव क्या होती है? दिस इज अ कंप्लीट वेव. पाई बाय 2 इज लाइक 1/4 ऑफ अ वेव. गॉट इट?
Yeah.
देन 180 हाफ साइकिल पाई की इक्वल है, और नंबर ऑफ वेवलेंथ क्या है? मतलब इट्स हाफ वेव. देन 3/4 वेव विच इज 3 पाई बाय 2 रेडियन एंड 270 डिग्री, जो ये वाला पॉइंट है. This represents
Mm-hmm.
270 degree, 3 pi by 2 radian, but it's 3/4 of a wave. फिर ये वाला
Okay.
point is 360 degrees, 2 pi radian, and this represents a whole complete lambda. यहाँ पे की पूरी
Lambda. Okay.
फिर एक और आप ऐसे यहां तक बना दो, दिस वन
which will be 540.
0.5 एग्जैक्टली। फिर एक और कंप्लीट कर दोगे तो वो 720 हो
So
जाएगी।
each of them is half. Each of them is half.
एग्जैक्टली ठीक है। एक पाई का
So
क्या मतलब है? वन लूप। दो लूप
yeah.
हो जाएंगे तो 2 पाई मेक्स वन वेव।
Mm-hmm.
A wave fronts is also another term. When you're going on an aeroplane, you have traveled, obviously. Now, you see from an aeroplane, how do you see the water waves? What do they look like? Do they look like this 3D, or do they look like something like this?
Looks like on the left.
Exactly. Because it's a plane view. Now,
Yeah.
actually, this is what? When someone looking
Just
at a
waves.
beach, कोई जो बीच पे खड़ा होगा वो तो ऐसे देख रहा होगा। So wave fronts
Mm-hmm.
are the imaginary lines that are used to represent the points on a wave that are exactly at the same phase position, perhaps the crest. अब ये जो वेव फ्रंट्स होते हैं क्या होता है? वी हैव अ लॉट ऑफ वेव्स। लेट्स से ये वेव जा रही है, फिर एक ये वेव जा रही है, फिर एक ये वेव जा रही है। बट द पॉइंट, देयर इज अ इमेजिनरी पॉइंट दैट इज गोइंग टू जॉइन ऑल दीज क्रेस्ट्स। इनको हम क्या कहते हैं? वेव फ्रंट्स। गॉट इट?
Yeah, right.
दैट पास थ्रू ऑल द सेम इन फेस पॉइंट। जैसे ये या तो सारे पास करें ऑन दिस पॉइंट ऑफ एवरी वेव, और द सेम लाइन passes थ्रू दिस पॉइंट ऑफ दैट वेव एंड दिस पॉइंट ऑफ दैट वेव, और जो अगली वेव का भी ये वाला पॉइंट होगा वहां पे पास करें। दे आर गोइंग टू बी इक्वल डिस्टेंट फ्रॉम ईच अदर। वेव फ्रंट्स आर द इमेजिनरी लाइंस। इसी तरह फिर वेव सुपरपोजिशन एक नया टॉपिक आता है, विच इज अ होल नेक्स्ट लेवल टॉपिक दैट वी आर गोइंग टू डिस्कस। तो व्हाट इज सुपरपोजिशन? Superposition means interference. Superpose. For example, this is one wave and this is another wave. When they combine together, they become this. What has happened? Can you tell me?
Yeah. It would be
What do you think happened over here?
well,
Wave A combined with wave
it
B to produce a wave C
it
which has
will
double the amplitude.
double,
Exactly.
but yeah.
इसको कहते हैं प्रिंसिपल ऑफ सुपरपोजिशन। व्हेन वेव्स मीट, each will be trying to cause a wave displacement according to its phase at the location, and the overall displacement will be the vector sum of the displacement caused by the individual waves. We call it superposition। कि जब waves meet करेंगी, the resulting displacement would be the sum of the displacements of both of the waves। अगर ये
Okay.
5
But is
सेंटीमीटर
that in the same direction?
सेम डायरेक्शन, वो टाइप्स होती है,
Yes,
वो
because
करेंगे।
opposite direction would cancel it out, wouldn't it?
ऑपोजिट भी होंगी, सेम भी होंगी। वी आर गोइंग टू टॉक अबाउट बोथ। अभी देखते हैं कैसे।
Okay.
अब एक 5 है और एक 3 है। सो द रिजल्टिंग प्रिंसिपल ऑफ सुपरपोजिशन सेज दैट व्हेन टू वेव्स traveling in the same direction meet at a point, the resultant displacement would be the sum of both of the individual displacements। Got it? And afterwards, each wave will continue past each other as the energy progresses in the same direction it was originally traveling. This can be most simply illustrated if we consider just wave pulses passing each other as in figure D as well। अब यहाँ पे देखो, ये अब दो opposite direction में आ रही हैं, they are going to collide। यहाँ पे हो गया। फिर what has happened when they collided? The resulting one, this was 2 centimeter, let's say this was 1 centimeter. The result became what after collision? 3 centimeter। Got it?
Yeah.
Good. So wave pulse displacement add when they meet in the same location. In wave pulses in figure D, they are traveling on surface of water. Then each would be trying to displace the water molecules upwards. तो वो उनकी डिस्प्लेसमेंट, उनका एम्पलीट्यूड बढ़ेगा। दोनों एक दूसरे को लिफ्ट करेंगे। पल्स बी भी लिफ्ट करेगा, पल्स ए भी लिफ्ट करेगा, जस्ट अ लिटिल बिट हायर टू द लेवल ऑफ द टू पल्स डिस्प्लेसमेंट्स एडेड टुगेदर। This effect is thought to explain the tales from sailors when they saw a sudden very, very large wave, which then dissipated as quickly as it appeared. With many waves traveling in many different directions, they might be at the same point at the same time. And adding these together
Mm-hmm.
in wave superposition could cause a huge displacement at that moment. It then drops again as the waves continue past each other। तो ये होता रहता है। इसी तरह waves
Mm-hmm.
बनती हैं, waves कम हो जाती हैं। So superposition of continuous waves, if rather than a single point along the path of the waves, we consider waves superposing over a large space, and the outcome is continuous wave where the sum of the displacements over time in each location, let's say अगर दोनों waves in phase हैं, उनमें एक large amplitude बनेगा जिसको हम कहेंगे this is constructive interference। But when two waves meet which are exactly out of phase, वो उसका रिजल्ट होगा डिस्ट्रक्टिव इंटरफेरेंस. गॉट इट? कैसे?
Yeah.
नाउ इमेजिन आई गिव यू टू एग्जांपल्स. ये है, वो बल्कि दी हुई एग्जांपल. ऑन द लेफ्ट यू कैन सी दीज आर टू वेव्स, दोनों इन फेज है. 90 डिग्री इन फ्रंट ऑफ द अदर वेव्स 90 डिग्री. ये सारे इन
Mm-hmm.
फेज पॉइंट्स है ना, इन लाइन आ रहे हैं सारे. These are the two
Yeah.
waves which are in phase with each other. मतलब this point is exactly in front of this point. तो इनका जो sum होगा, let's say this is 2 centimeter, this is 2 centimeter amplitude. Their sum would be 4
To be
centimeter.
4 centimeter.
We say that these waves are in phase. अगर दो waves हैं जो
So
out of
they're
phase,
in sync.
ठीक है ना? बिल्कुल वो sync है. In phase means they are sync.
Mm-hmm.
Good word.
Yeah.
Now, अब जो other wave है वो out of phase है. मतलब कि इसका 90,
Minus basically.
हाँ, इसका 90 डिग्री उसके 180 से मैच कर रहा है. ये तो रॉन्ग है, दे आर नॉट इन फेज. ऊपर वाली
Yeah.
जो वेव थी देवर एग्जैक्टली सिंक्ड.
Opposite.
बट यहाँ पे क्या है, एक ऐसे तो दूसरी ऐसे आ रही है. नाउ दीज आर
Mm-hmm.
आउट ऑफ फेज. आउट ऑफ फेज का जो रिजल्ट होगा दैट वुड बी जीरो. वी कॉल
Mm-hmm.
दैट डिस्ट्रक्टिव इंटरफेरेंस. एंड जहाँ पे
Okay.
एम्पलीट्यूड डबल हो जाता है, दिस इज नोन एज कंस्ट्रक्टिव इंटरफेरेंस.
So they would cancel each other out in the destructive interference.
एग्जैक्टली जीरो
Where
एम.
you just flatten out.
यप, वो जीरो है, सब्ट्रैक्ट भी नहीं, जीरो. Whatever the value
Okay,
is,
just nothing.
zero, nothing, exactly.
Okay.
It's important to know the phase difference between the two waves in order to determine what will happen as a result of the superposition, which would be our tomorrow's topic. जब हमने stationary waves, सबसे tough topic of your A-level physics is the stationary waves. और ये सारी जो आगे अभी calculations आएंगे, waves is not easy. Electricity would be easy. Waves is much tougher than electricity. Waves that constructively interfere as with the top pair must be in phase. एंड दे हैव अ फेज डिफरेंस ऑफ जीरो. इनका जो फेज डिफरेंस है वो जीरो है. मतलब कि अगर ये भी 90 पे आ रही है तो इसके सामने वाला पॉइंट भी 90 पे ही है, तो 90 माइनस 90 जीरो है. इसके 180 वाले पॉइंट के सामने 180 आ रहा है, 270 वाले के सामने 270 आ रहा है, दैट इज जीरो. बट यहाँ पे अगर इनका फेज डिफरेंस देखो, हाउ मच आर दे आर एग्जैक्टली 180 डिग्री फेज डिफरेंस फ्रॉम ईच अदर. तो देर इज अ फेज डिफरेंस ओवर हेयर एंड हेंस इट इज डिस्ट्रक्टिव इंटरफेरेंस. गॉट इट?
Yeah.
So constructive interference are either which have a zero phase difference or which have a 360 phase difference, because 360 भी वही चीज है. ये wave
Yeah. It
और
would just
ये,
flip around.
exactly it would be exactly almost the same, वो भी 360 है. Destructive interference कैसे होंगे? Either it's 180 or it's 270. If
Okay.
the phase difference is 180 or 270, there's going to be destructive interference. And if the phase difference is 0 or 360, it's gonna be constructive interference. Got it?
Yeah.
Wavefronts lines connecting points on the wave that are exactly at the same phase position. Superpositions when more than one wave is in the same location. The overall effect is the vector sum of their individual displacements. Constructive interference is the superposition effect of the two waves that are in phase, producing a larger amplitude resultant wave. And destructive interference is the superposition effect of the two waves that are out of phase, producing a smaller amplitude resultant wave.